So in this problem, we're told to evaluate the integral from minus 2 to 3 of x minus 4 times the absolute value of x dx. So in order to solve this problem, what we're going to do is split it into two different integrals. And you'll see why, because of the absolute value. And so we're going to have two integrals. So we're going to start with our lower bound on this one right here. So plug in your lower bound, and it's going to go all the way up to 0, right? We're going to make our distinction at 0 because absolute value changes at 0. And then so it's gonna go 0 right here too, right? Because it goes 0 to 0. And then at the top on this one, we're gonna have our upper bound. So that's gonna be 3. And then for the functions you're gonna plug into it, the one that's from negative to 0, right? You're gonna plug in a minus x for your absolute value, wherever that is. And then for the positive one, right, this one, you're just gonna plug in x. So this one's gonna become x minus 4 times minus x dx. Then we're adding these two integrals together, by the way. And then it's gonna be x minus 4 times just x. Now we've set it up, all we have to do is solve basically. So actually we can simplify this a bit more. So x minus 4 times minus x is just going to be x minus minus 4x. So it's the same thing as adding them. So x plus 4x is going to become 5x. So minus 2 to 0 of 5x dx plus this one's 0 to 3. And then x minus 4x is just going to become minus 3x. So minus 3x dx. And all we got to do is solve. So we have 5x here. We evaluated 0, minus 2. Or we got to take the antiderivative first. So the antiderivative of 5x is going to be, we add 1 to our exponent, right? So it's become x squared. We divide by that exponent, divide by 2. Then we multiply by 5. So it's going to become 5 over 2 x squared. We're evaluating that from 0 to minus 2. And then we're adding that value to the antiderivative of this evaluated at that. So minus 3x is going to become, we add 1 to the exponent. So 1 plus 1 is 2, divided by 2, multiply by our constant. So it's going to become minus 3 over 2x squared. So plus minus 3 over 2x squared, evaluated from 0 to 3. Let's go ahead and solve. So if we plug in 0 into this, 0 squared is 0, times 5 over 2 is just 0. So we have 0 minus, and then we're plugging in minus 2. So minus 2 squared is 4. 4 times 5 over 2 is 20 over 2. 20 over 2 simplifies to 10. So we have 0 minus 10, which just becomes minus 10. So we have minus 10 right here, plus this this thing evaluated. So if we plug in 3, 3 squared is 9. And then we're multiplying it by minus 3 over 2, which will become, well, 3 times 9 is 27. So minus 27 over 2. Then we're minusing whatever it is at 0, plugging in 0. 0 squared is 0, times 3 over 2, or minus 3 over 2, gives us 0. So it's just minus 27 over 2. So it's minus 10 plus minus 27 over 2. Right? So if we go ahead and do that, I'm going to make the minus 10 to be over 2, right? So it's going to become minus 20 over 2, because that's just the same thing. Minus 20 over 2 minus 27 over 2 becomes minus 47 over 2. So this right here is going to be our final answer. So the answer to this problem is going to be minus 47 over 2.